Hello friends, this video on CET NEET crash course on motion in a straight line is brought to you by Pratibimba Learning by Reflection. This video will have more solutions for MCQs on the chapter motion in a straight line. Subscribe our channel and also share this video for students who are preparing for CET and NEET examination. Let us begin with the video. Question says, a stone falls from the top of the tower in 8 seconds. How much time will it take to cover the first quarter of the distance starting from the top? So it is given that the stone is falling from the top of the tower. The stone has fallen from the tower and it took 8 seconds to reach the ground. It is also asked about the time it is going to take to cover first quarter of the distance. Let us mark the total distance as S. S is the total distance the stone needs to travel to reach the ground. Let us find that distance first with the given data. It is told that the stone is being dropped from the top of the tower. What about the initial velocity in such case? U is equal to 0, right? We have the equations of motion, that is the second equation of motion, that says S is equal to ut plus half at square. What about this first term? That is equal to 0, right? Because u is equal to 0, that is the initial velocity is 0. I'll write distance s as equal to half. What about a? Here, acceleration a needs to be replaced with g, acceleration due to gravity. What about the time taken by the stone to reach the ground? It took 8 seconds, right? I'll write 8 square. What about the distance traveled now? It is half into g into 64, which says the distance traveled as 32 g. Since they have not given us with the value of g in the question, let us assume it to be g only. Moving back to the question, how much of time did it take to cover the first quarter of the distance? The total distance is, yes, first quarter of the distance will be 1 by 4s. I'll write it. First quarter of total distance, which will be S1. I'll write it as S1, that is equal to quarter of the total distance, S by 4. It becomes 32 by G, 32G by 4, which is equal to 8G. This is the first quarter of the distance. They have asked how much of time did it take to cover the distance 8G. I'll write time taken to cover the distance S1. Cover S1. Again, we are going to use the second equation of motion here. S1 is equal to ut plus half gt square. Here also the initial velocity will be 0. We are left with S1 is equal to, so I'll write the symbol for time as t1, because t1 is the time taken to cover that first quarter of the distance, right? It is half g t1 square. What about this s1? It is equal to 8g. S1 is equal to 8g, half g t1 square, which cancels g and g on both sides. T square will be 16. Therefore, T is equal to 4 seconds. And the correct option here is option A, 4 seconds. Moving on to the next question. A stone is dropped from a height 45 meter. What will be the distance traveled by it during the last 1 second of motion? The question is about the distance traveled in the last 1 second. Before we calculate the distance traveled during last 1 second, what is the total time it took to cover a height of 45 meter? I'll draw the diagram. The stone is falling from the tower, and what is the height? Let us say it is 45 meter. The stone is falling from a height of 45 meter. They have asked us what is the distance traveled at the last 1 second of the journey. How much of distance did it cover at the last 1 second? S is what we have to calculate. That is our SN. Distance traveled in nth second. Before that, we need to find how much of time did it take to cover this distance of 45 meter. What about the initial velocity here? Initial velocity, we must note always that if the object is falling from certain height, its initial velocity will be 0. How much of distance did it take? 45 meter. What is given as the value of g? 10 meter per second square. Now we will calculate the time taken by the stone to reach the ground covering a distance of 45 meter. We have the second equation of motion, S is equal to ut plus half at square, right? So that makes u to be 0. What about S? It is 45. The total distance covered, half. Since the stone is falling from the top to bottom, acceleration due to gravity is g. What about the time taken? That's what we have to calculate. It is written as t square as it is. I'll get the value of g if it is given in the question, that can be substituted, right? G as 10 t square, which makes t square 5t square as equal to 45, or t square is equal to how much? T square equal to 45 by 5, right? T square equal to 9, and hence t is equal to 3 seconds, which says that the stone took a total of 3 seconds to reach the ground. The question is about what is the distance traveled in last 1 second, which is the last second of the journey. It is 3 seconds. That is why we have to consider a formula. Sn is equal to u plus a by 2 2n minus 1. That is the equation for distance traveled in nth second. Distance traveled in nth second is given by Sn is equal to u plus a by 2 2n minus 1, right? What about our value of n? It should be equal to 3. Why? Because they have asked us to calculate distance traveled in nth second. So that we have to substitute n as 3. S3 is equal to, what about initial velocity here? It is 0, plus g will be our acceleration due to gravity, that is 10. I'll be replacing a with the g here, it is 10 by 2, 2 into 3 minus 1, or I'll write S3 is equal to 5 of 6 minus 1, 3 to the 6, 6 minus 1 is 5, hence S3 is equal to 25 meters. Okay, what about the right option from the four given options? It is option C, 25 meter. I hope you are clear with this. Moving on to question 13. This time the stone is thrown vertically upwards. I'll read out the question. The stone is thrown vertically upwards with the velocity of 30 meter per second. If the acceleration due to gravity is 10 meter per second square, what is the distance traveled by the particle during the first second of its motion? This time a person is going to throw the stone upwards. Okay, the stone is moving upwards. What about its initial velocity? It is given to be 30 meter per second. It is given in the question. The stone is moving vertically upwards with the velocity 30 meter per second, which is our initial velocity. What is the acceleration due to gravity here? They have given us to be 10 meter per second square. What is the distance traveled by the particle? We have to find the distance traveled s by the particle during the first second of its motion. What is the distance traveled in first second is what we have to find. Let us say the distance traveled from here to here, that is when n is equal to 1. Clearly it is told the distance traveled in first second needs to be determined. That is when we have to take n is equal to 1. We have to find s1 is equal to how much, right? What is the equation to find the distance traveled in nth second? We have Sn is equal to u plus a by 2, 2n minus 1. Hence I'll write S1 as equal to, what is u here? It is 30 plus a will be taken to be g, acceleration due to gravity, which is 10 by 2, 2 into 1 minus 1. Am I right? Then what about the simplification part? You will get 30 plus 5, 2 minus 1 is 1. Hence the answer is okay. Here, acceleration due to gravity is 10 meter per second square for an object that is moving vertically upwards. Acceleration due to gravity is negative. Alright, minus 10, and here also the sign will be negative, right? You will get 25 meter as the answer, right? Since acceleration due to gravity is minus 10 meter per second square for an object that is moving vertically upwards, hence we are going to substitute the value of a as minus 10, and hence distance covered in first second of its motion is 25 meter. What is the correct option among the four given options? It is option B. Moving on to question 14. The ball is thrown vertically upwards with the velocity of 30 meter per second. This time the ball is again moving vertically upwards. How much is the velocity of it? 30 meter per second. Acceleration due to gravity. Since the body is moving vertically upwards, acceleration due to gravity will be negative. What will be the distance traveled in the last second of its journey? They did not say whether it is the first second or third second or fourth second, nothing. We don't know the value of n here, right? The last second itself is told. What will be the distance traveled in the last second of its journey is what we have to calculate. Here, firstly, we need to calculate the total time taken for the entire journey. What about the initial velocity? It is 30 meter per second. Acceleration due to gravity is minus 10 meter per second square, right? What about the velocity, which is our final velocity here? If an object reaches the topmost point, its final velocity there will be 0 meter per second, because at the highest point the final velocity is 0. Let us calculate the time taken for the object to reach the topmost point. We have v is equal to u plus at. V is 0, u is 30. Acceleration due to gravity is minus 10 into t, or 10t is equal to 30. T is equal to 3 seconds, which means that the body has taken 3 seconds to reach the topmost point. Now we can calculate the distance traveled in the last second. Which is the last second here? That is at third second, right? Distance traveled in third second is, the formula is Sn is equal to u plus a by 2. You can also write it as g by 2, 2n minus 1. What is the value of n for us? It is n equal to 3. The last second is nth second, which is 3. S3 is equal to u is 30 plus a by 2 will be our g value, minus 10 by 2, 2 into 3 minus 1. On simplification we get 30 minus 5 into 5, right? 30 minus 25, that is equal to 5 meter, which means the object has moved for a distance of 5 meter at third second. It is not t is equal to 3 second. It is n is equal to 3, which means that at third second the object has traveled a distance of 5 meter. Which is the correct option from the given 4 options? It is option A, 5 meter. Moving on to question number 15. A particle moving with constant acceleration covers a distance of 30 meter in third second. 30 meter in third second. I'll write it down. It covers a distance of 50 meter in fifth second. 30 meter in third second. 50 meter in fifth second. This is what they have given. What is the acceleration of the particle? We have to find the acceleration of a given particle. They have given the distance traveled in third second. That means it is S3 equal to 30 meter and S5 is equal to 50 meter. They have not given us with the initial velocity, they have not given us with the acceleration. The same particle is traveling means its initial velocity will be the same, right? We are assuming our initial velocity as u, and the expression that we are going to consider here is this one. Sn is equal to u plus a by 2, 2n minus 1, that is equal to What is u here? Let us assume it to be u itself. We don't know the value of acceleration, we'll write it as it is. N here is, in this case, n is equal to 3, right? The first equation. Let us write the equation for this. S3 is equal to 2 into 3 minus 1. S3 is 30, right? Which gives us u plus a by 2 into 3 2s are 6 minus 1 is 5. We have 5a by 2. This is our first equation. Similarly, writing the equation for this, S5 is equal to 50 meter where n is equal to 5. I'll write S5 is equal to u plus a by 2, 2 into 5 minus 1. I'll write u plus 9a by 2. S5 is 50. Right? This is our equation number 3. So using equation 1 and equation 2, let me subtract one equation with the other. Equation 2 minus equation 1 gives us 50 minus 30 is equal to u plus 9a by 2 minus u plus 5a by 2. Or I'll get, by cancelling u and u, 9a by 2 minus 5a by 2, that is equal to 20. 20 is equal to 4a by 2. Therefore, a is equal to 40 by 4, which is equal to 10 meter per second square. The correct option among the given 4 options is option D, 10 meter per second square. Thank you for watching. Subscribe the channel for more videos.